Hello everyone. So today we are going to discuss about a concept which is covered under radiation biology, that is interaction of X-rays with matter. Okay. So when do the X-rays go ahead and they interact with matter? In radiation physics, if you see, which is the very first chapter of our oral radiology, the chapter ends with production of X-rays, right? So how are the X-rays produced? They are basically by two methods, isn't it? So we had spoken about Bremsstrahlung and characteristic radiation under the heading of production of X-rays. Okay, so now the major motive of we producing the X-rays after all those circuits that we did, right, within the X-ray tube, the cathode, the anode and all those things, whatever we had discussed, the entire process was meant to produce the X-rays, and these X-ray photons move out of the X-ray tube head after having crossed through the barriers of filtration and collimation, and then they interact with the tissues. Now when they interact with tissues, then only over a process of attenuation and absorption, which are the most important properties of X-rays, we get to have a radiological image of the anatomy that we are intending to look deeper into, right? So there are different ways in which the X-rays interact with matter, okay, as highlighted here: coherent scattering, photoelectric absorption and Compton scattering. These are the three most important ways which the X-rays use for interacting with the tissues. Other than these three, there is also some amount of no interaction which happens at all. That means there are some X-rays which do not react with the tissues, do not react with the matter at all. Okay, so when this question comes in exam, what you are supposed to put on the paper is first, what kind of an interaction is this? What are the various other names of each kind of interaction? What is the percentage for each interaction? How does the process happens, that is the procedure happen, and whether it is of use in diagnostic radiology or not. Okay, along with a suitable diagram, because diagrams are very important to depict where are the X-ray photons going on and hitting, and what is the entire sequence of events which is taking place once they interact with the tissues. Okay, so we'll see once we go ahead. So now here X-rays thus produced. Where are they produced? Within the X-ray tube. Okay, they pass through the filter, isn't it? So filter, what does it do? It filters out the low energy photons and allows only the high energy X-ray photons to pass through, so that there is no any amount of film fogging can be prevented. Okay, so then it interacts with the living tissues. Okay, so finally these X-ray photons then go, they in the form of, so now when they interact with the body, here although I have shown a picture of a full body, but we are concerned only about the head and neck region, isn't it? So once it interacts, there are two things which may happen here. Forget about the types of interaction, that we will see later. First, immediately at the juncture of interaction, there are two things which happen. One is absorption, one is scattering. Okay, so few X-ray photons, they will go and get absorbed, and this degree of absorption or your absorption coefficient is determined by the density of the tissue it is interacting with. Like for example, if it is interacting with a bone, which is a dense object, so once it interacts with a dense tissue or a dense entity, the absorption is more. So that is why that particular object appears radio opaque or radio or whiter on the radiograph, whereas the hollow tissues, right, or the soft tissues, like for example your canals, your foramens, okay, your fossa, they are all hollow structures. Your sinus, right, they allow most of the X-ray photons to pass through, they absorb very less. That is why they appear black or radiolucent on the radiographic image. Is that okay? This was about absorption. Now other than absorption, otherwise also in the subject of physics and chemistry, we would see that whenever any kind of rays or any kind of energy, when it goes and hits a particular structure, either there is reflection or there is refraction or there is absorption or there is scattering, isn't it? Or there is no interaction at all. So this was first proven where your Rutherford's gold foil experiment, isn't it? So reflection, refraction, absorption, scattering and no interaction. So here for your X-rays to form, X-ray photons to form image on the radiograph, we are basically concerned about absorption and scattering. Okay. Next is now per se, once the X-rays thus produced, they are directed towards the object of interest. Okay. Now, this interacts with the atoms of the object it hits. Like for example, every structure has got a particular chemistry, right? It has got atoms, it has got molecules, it has got neutrons, protons, nucleus, all those structures, right? So there are basic 4 ways in which these X-rays interact with matter, thereby getting attenuated. What do you mean by attenuation? Reduction in the kinetic energy of the X-ray photons. So as I told you, attenuation and absorption are very, very important phenomena to happen if you have to obtain a radiographic image. Okay. So based on these properties, your X-ray photons, they pass through the object either in the form of coherent scattering or photoelectric absorption, Compton scattering, pair production and photo disintegration. These are the types of interaction of X-rays with matter. So how many are there? 5. And the last one, that is 6th one, is no interaction at all. Almost about 9 to 11% of no interaction happens with the tissues at all. Okay. So let's get into the deeper aspects. Now, what is the importance of these kind of interactions of X-rays with matter? Your coherent scattering is not important in any energy range for our use in radiology or diagnostic purpose. Okay. Your Compton scattering, photoelectric scattering are used for the purpose of diagnosis in oral radiology. Okay. And pair production and photo integration are utilized for therapeutic radiology. What do you mean by therapeutic radiology? Radiotherapy that we do. Okay. Any kind of radiation induced treatment or therapeutics that we perform or we carry out is basically utilizing pair production and photo integration kind of interaction of X-rays with matter. Is that okay so far? So either it will be of no use at all, but the energy is definitely produced. Second and third, they are for diagnostic radiology, and pair production and photo disintegration are for therapeutic radiology. Clear so far? I hope no doubts. Okay. Next we move on to the interaction of X-rays with matter forms the basis of radiographic image on the radiograph. Okay, this we have already been discussing so far. So at different energy levels, the X-ray photon interacts with atoms of the matter and causes a differential absorption of X-rays by the body tissues. For example, what do you mean by differential absorption? Based on the density of the tissue, the kind of interaction, absorption, scattering, everything will be different. Okay, so for example, the bone absorbs more X-rays compared to the soft tissues because it's a denser structure. On a radiograph, bone appears more whiter or radio opaque compared to a soft tissue entity which appears either black or, in other words, we call it as a radiolucent image, right? So all these are the basic fundamentals that we need to know before we study the interaction. Next, we begin with the first kind of interaction, that is your coherent scattering. Okay. Your coherent interaction is also called as, you can remember it by the word CET, set. That is classic scattering. E is for elastic scattering. T is for Thomson scattering. Okay. And there is also a fourth name to it that is called as Rayleigh scattering. R-A-Y-L-E-I-G-H. Okay. So your coherent scattering is also known by 4 other terminologies, that is CET-R. That is classic, elastic, Thomson and Rayleigh scattering. Is that okay? Now, this occurs within the energy levels of below 10 electron volt. So, if it is below 10 electron volt, that means it is not of any use in our radiology purpose. That is either, neither in your therapeutic nor in terms of diagnosis. Okay. Next, the incident X-rays when passing close to an atom. This is the procedure of how exactly it is happening. I will also explain with the depicted diagram. So please do not worry. Try to understand. Let's go step by step. So what does it do when the X-ray photons are coming from the X-ray tube? Okay, they pass very close to an atom, meaning to say they are not colliding with the atom, mind you. Okay. So that is why it is scattering and not collision. Okay. So they pass very close to an atom, and what is the purpose of passing very close to it? They excite the bound electrons momentarily. Where are the bound electrons we are talking about? these bound electrons are in the shells and subshells, your K, L, M, N, all those things. Okay? So these electrons, close to which the X-ray photons pass, they excite them momentarily at a frequency equal to that of its own energy. Okay? So like suppose this is your X-ray photon which is traveling. Here is your electron which is bound to the nucleus in any of the shells. So when it goes, it passes very close to it. And moment it passes very close to it, it excites this particular electron. So moment this electron gets excited, it releases some amount of energy. How much is the amount of energy released? It is same as the amount of the energy which is carried by this incident photon, this incident X-ray photon. Is it clear? So this is how your amount of energy is released in case of coherent scattering. So what is exactly happening here? If you can see an incident X-ray photon which is coming from the X-ray tube, it passes very close to a bound electron. Moment it passes very close to the bound electron, it ceases to exist. That means it dies. Okay, it gets finished there because its energy is gone. On the other hand, this excited electron which was bound there, that releases energy. And that releases how much amount of energy? The energy which this incident photon was carrying when it was coming from the X-ray tube. So this is all about your coherent scattering or classic scatter or elastic scattering or Thomson scattering or Rayleigh scattering. Is that okay? Next is your coherent Next is your photoelectric absorption, okay, which takes place in 30% of photons from the dental X-ray. So what does it say? It normally occurs when the X-ray photons of around 70 kilo electron volt colloid with a bound electron in the atom. Okay, here the X-ray photons which are coming, they bang on to your bound electron. There was no collision as such happening. It was passing very close to it. Like in which phenomena? Same like your Bremsstrahlung radiation. There was also a near miss, right? And here in your previous one also, there wasn't any collision. But here it collides with a bound electron in the atom. So after the X-ray photon and the bound electron, they collide with each other. On collision, the photon ceases to exist, meaning the photon dies. Which photon? The X-ray photon. It will come, it will bang on to the electron, bound electron, and it will die. Okay? Next, its energy removes an electron from its orbit. So when there is a collision, this X-ray photon will die, whereas this particular electron is knocked out of its place. Okay? So this electron which is knocked out from its place is called as a recoil electron. Okay? Always remember, it's a Viva question. What do you mean by a recoil electron? So that is it. And this recoil electron is also called as a photoelectron. The energy which is imparted to the recoil electron, that means when it is knocked out, it carries some amount of energy with it. This energy of the so what is that energy? It is energy of the incident photon which was coming minus the energy required to overcome the binding energy. So obviously when you are knocking out one particular electron, you will have to give more energy than what it already has, right? Because it is closely attached to the nucleus. And when any electron is attached to the nucleus, it is held to that particular shell or subshell with certain amount of binding energy. So if I have to throw this electron from here, I have to give definitely more amount of energy than the binding energy of this particular electron. So that is why the energy of the recoil electron is calculated as energy of the incident photon which came and banged minus the binding energy of this particular electron before it was knocked out. Is that clear? I hope it is fine for you all now. So the electron removal causes ionization. What is ionization? The process of converting an atom into an ion is called as ionization. And the vacant valency will be filled. Now when this is knocked out, there is a valency or a void created. So this void will be filled by what? An electron from the higher orbital or higher energy level which pops down. Okay? Same procedure which we had seen in characteristic radiation. Okay, in the higher orbit, thus releasing a characteristic radiation. So your photoelectric absorption also has properties of your characteristic radiation. So this is what exactly happens when there is an incoming X-ray photon, which is also called as incident X-ray photon. It comes and hits one of the electrons here. Okay, so there is a collision. This electron is knocked out as a recoil electron, and the energy released by this recoil electron is equal to the energy of this incident photon minus the binding energy of this recoil electron, and that is your energy of the photoelectron, and that is how energy is released in case of photoelectric absorption. Is that clear? So this is the process. So same thing, if we depict it in the form of an animation, what would happen? There is an electron which goes and hits, okay, knocks it out in the form of a void, in the form of a recoil electron, thereby creating a vacancy here, okay, that is a void there. So now what will happen? This higher energy electron will come and drop down here, okay, and so what is the precursor, what is the repercussion of this? The energy which is released by your recoil electron is the energy of the incident photon minus the binding energy of the knocked out electron or the recoil electron. Is that okay? Next, we move on to Compton scattering. Okay, the third one, also called as inelastic scattering. Your first one, that is coherent, was called as classic elastic scattering. This is inelastic. So it is an interaction of X-ray photons with free or loosely bound outer shell electrons. Okay, so the photon gives some amount of energy to the electron with the X-ray photon which is coming. Definitely when it will hit, some amount of energy transfer will definitely take place, isn't it? So removing it from the orbit, and it itself is scattered or continues in a new direction. That means in the first one, like how after passing close to it, the X-ray photon had died, it ceased to exist. Okay, but here after knocking it out, it moves in some other direction. It does not die. And when it moves in some other direction, it keeps on interacting with further atoms which come on its way till the time it dies and ceases to exist. Okay, and it will keep imparting its energy. So every time it will bang, it will continue, bang and move on, collide and move on. So whenever there is a collision, it will keep imparting its energy till the time all its energy is over and it dies. Okay, so now it itself is scattered or continues in a new direction with a reduced amount of energy. So every time it is colliding, it is reducing, its energy is getting reduced. Finally, the energy will become zero and it would die. So the ejected outer shell electron is called as a Compton electron. So this is how exactly it happens. There is an outer shell electron which is the target. In your photoelectric, it was an inner shell electron. But in Compton, it is an outer shell electron in the body which interacts with X-ray photon from the tube. Okay, so when there is an incoming X-ray photon, which is also called as incident X-ray photon, okay, it interacts with an outer shell electron. So when there is an interaction with outer shell electron, this electron is knocked out in the form of a recoil electron, and that is called as a Compton scattering or a Compton electron. On the other hand, this incoming X-ray photon after collision, it will move ahead. Okay, there is scattered photon with less energy. So that is why this is called as Compton scattering, because there is a production of a Compton electron plus there is also scattering of the X-ray photon. Okay, so with a reduced amount of energy, it will get scattered and move ahead, and it will keep interacting with other atoms on the way till the time it would have lost all its energy and it would cease to exist or it would die. So that is how the three major important interactions of X-ray with matter happens. Okay, I think it is clear. So with these concepts, we say that importance of photoelectric and Compton absorption in diagnostic radiology is very prominent. Okay, it relates to the difference in the way photons are absorbed in various anatomical structures. Okay, now the above interactions are more probable in hard tissues and less mineralized soft tissues. I mean, compared to the less mineralized soft tissues. So the resultant X-ray photon existing in object exists due to this differential absorption. What differential absorption? In some, it will go and interact with the innermost electron, like in photoelectric absorption. In some, it will interact with the outermost electron, like in your Compton scattering. Okay, so that produces ultimately a readable image on the image receptor, that is a film, due to differential exposure of silver halide crystals. So always remember, there are two questions in this. Till now, we were talking about attenuation, absorption and all that. But now that we have understood the concept of interaction of X-rays with matter, we need to know that the image after attenuation, absorption, everything that has happened, it is finally produced because of differential exposure of silver halide crystals. Okay? So, then the concept of secondary electrons came. Secondary electrons can sometimes be asked in Viva or maybe a 2-mark question. Okay? So, you just need to know that in both the photoelectric and Compton reactions, electrons are ejected from their orbits. So, when the electrons are ejected from their orbits, we were calling them as recoil electrons. Same recoil electrons are also called as secondary X-ray photons. Okay, because they are knocked out by the primary or the incident X-ray photon. That is why they are called as secondary photons or secondary electrons, whatever you call them. Okay, so that is how. So these secondary electrons eventually dissipate all their energy, mostly as heat, by collisional interaction, and then they come to the rest. Okay, so why collisional interaction? Because they are formed as a result of collision. So that is how the process talks about. So if we have to summarize the thing, interaction of X-rays, what do we say? You have the X-ray photons coming out of the position indicating device of your X-ray tube, and then they are going and interacting with your tissues, okay, with the matter, that is hard and soft tissue. So because of that, the interaction happens in what all ways? Important ones, the coherent, the photoelectric and Compton. Compton also called as inelastic, coherent also called as classic, elastic, Thomson and Rayleigh, right? And out of these three, photoelectric and Compton being of use in our diagnostic radiology, pair production and photodisintegration being used for our therapeutic radiology. Okay, so finally, when the interaction takes place, it is because of release of X-ray photons colliding with electrons in different levels of the molecules or electrons in the orbit of the tissues. Okay, so because of that, ultimately, what do we get? The images formed because of differential absorption of differential exposure and absorption of your silver halide crystals. Is that clear? So that is all about your interaction of X-rays with matter, which is very important, and this is your first concept which is discussed in textbooks under the topic called as radiation biology. Okay, thank you.